pausing for a minute while I pin my window so I can see better what I'm writing. Here we go. All right, so what I'm about to show you or teach you about is writing formulas for binary compounds. So they are called binary compounds of two non-metals. So binary compounds of two non-metals. So that would mean which one of these two compounds, for example, that one or that one. So which compound, left side or right side, is a binary compound of two nonmetals? Yeah, that's the right side, because nitrogen and oxygen are both nonmetals, but sodium we know is a metal. So that one would not apply. Which one of these two is two nonmetals? Left side or right side?
Right.
Okay, so if we look at a periodic table, let's take a quick look at a periodic table. On this periodic table, this little stair-step line right here separates metals and nonmetals. So elements on the left side are metals. Elements on the right side are nonmetals. And of course, everything down here is, almost everything is almost all are nonmetals. They act like nonmetals. A couple of them, the ones with chromium in them, they have a metal in them, but most of them don't even have any metals in them. Manganese is a metal, and that's in permanganate. Okay, so once again, metals are on the left side. Nonmetals are on the right side up here of this stair-step line. So there's a lot more kinds of metals than there are nonmetals. But nonmetals are more abundant on the Earth's crust than metals are. There's more of fewer things. All right, so the one on the left is the one with two nonmetals. All right, so when we name them, we sometimes use prefixes, and the prefixes tell you how many atoms are in the nonmetals. So I'm going to just list them. I think you'll recognize some of the words: mono, di, tri. This is one you may not recognize except if you played Tetris. Tetra means four. This one I think you will know. Hex you know, hept you may not know. Oct you know because an octopus has 8 legs. Non means 9, and you know there are 10 years in a decade, so dec means 10. So those are the prefixes that we use to indicate numbers of atoms from 1 to 10. So looking at a couple of examples, if I have that compound, N2O3, that would be called what nitrogen? Which prefix would you use? Can anybody tell me? Just yell it out. How many nitrogens?
2.
Yeah, so which one of these prefixes means 2? Di. So you would say dinitrogen, and you guys watch the chat also. And then how many oxygen atoms are there? 3.
3.
So which one means 3? Tri. So you'd say dinitrogen trioxide. So when you see a name dinitrogen trioxide, that means there's 2 nitrogens and 3 oxygens, and you don't even have to think about charge. You just go with the prefixes. All right, if I did this one, how many phosphorus are there? 2.
So it'll be diphosphorus and pentoxide.
Yes, very good. Very good. So diphosphorus pentoxide. All right, makes sense to everybody? So you say diphosphorus and then pentoxide. All right, you can even get crazy, you can get big sometimes, like the prefix for 4 was what? Tetra?
Tetra.
So tetraphosphorus, dec oxide. Okay, so in other words, you just use the prefixes to tell you how many atoms. Now there is one other little caveat. When we only have one atom of the first element, so I'll write that down. If one atom of first element then no prefix. Let me show you an example. So if you were going to name this compound, you wouldn't use a prefix for the first atom, but you would for the second. So what would that be called?
Carbon dioxide.
That's exactly right. And that's a famous compound. You know about that already, right? So carbon dioxide. If you had this compound, you know about this one too. That's carbon with one oxygen. So carbon
Monoxide.
Yeah, carbon monoxide. And usually we don't have a double vowel usually, so instead of saying monoxide, we just say monoxide. It just flows better. All right, so that's carbon monoxide. Which one of these is poisonous?
Carbon monoxide.
Yeah, monoxide is poisonous. That's why you have a carbon monoxide detector in your house. Remember we talked about this the other day when I showed you how the furnace worked on Tuesday? So if you have the broken heat exchanger, you got the potential for carbon monoxide to get in your house, and then it just puts you to sleep and you don't wake up. So, all right, so that was a quick lesson about prefixes. Is there any question about those?
Can you take a picture of this and put this in the classroom?
Yeah.
No, you take a picture. No, you take a picture.
Shut up.
You can take a picture of it right now if you got your phone. Can you do that?
I can't see the full paper.
Oh, pin the window. Everybody knows
I did. I can't see it, the bottom of it.
Oh, here we go. How's that?
Better. Yeah, keep it there real quick.
Okay. Let me see if I can
Raymond,
focus
send
it.
it to me, please.
No, take a screenshot yourself.
All right, there you go. If you can get a screenshot of that, then you've got it. All right, so the next thing on my list today is formulas and formula masses. And we're going to take about 20 minutes, maybe 25 minutes, to work on the next assignment. And for that assignment, I'm going to have you go into breakout rooms, and I'll try and come around and help you individually. Of course, I'm going to set it up so that you can move from breakout room to breakout room on your own if everything works properly. So I'm going to start everybody in one room. But if you want to work with somebody, you can. Just be sure that you're working. And then the other thing I'm going to say about it right now while I'm thinking about it is, you remember the strange names assignment? I made that so that you wouldn't be tempted to Google the answers and just write them down. But you also need practice today learning where the elements are on the periodic table. And so today's assignment is using real compounds. You can just Google those and find the answers, but you won't learn anything if you do that. So what I need you to do is take time to actually think about writing the formulas. And I will know if you've Googled them because I'll be able to see that the formula is not in the proper format, because often the internet doesn't give it to you in the right sequence. Okay, so I will do a couple and we'll review them, and Josh, I'll answer that question with the real compounds, real elements, and then you'll do it the same way for the strange names. All right, so let's take a look at the new assignment, and then I'll go do a couple of example problems for you. Now, I'm going to post this. I'm still recording this, so I'll post it on the website. When you watch it, there's there's downtime, so you'll have to just fast forward when it's appropriate. All right, so moving forward with the instruction on this next assignment. Notice it says read the directions. And we're going to read the directions together before I assign it. So here are the directions. This assignment is designed for you to practice writing formulas and calculating the formula mass. It's very important, as it really is the beginning of our unit on moles. So set up the quiz as shown in the screenshot and then submit your best score. Set up the quiz as shown in the screenshot. Please note, there are 3 polyatomic ions. Actually, I found another one. There are 4. How do you spell 4? F-O-O-U-R. 4 polyatomic ions on this quiz that do not match those on the class periodic table. They are. So monohydrogen phosphate is on the periodic table on the bottom of it, but it's there as, it just says it's hydrogen phosphate. Silicate is listed on our table as orthosilicate, but on this assignment, when they say silicate, they mean orthosilicate, and it has a SiO4 with a -4 charge. This doesn't show up very often in the assignment, but if it does, it always occurs in pairs. So this is mercury with a +1 charge. It's a strange diatomic or diionic ion. It always occurs as Hg2. So even though it's +1, there's always 2 of them, so it has a +2 charge. And then phosphite is kind of like phosphate, except it's 1 less oxygen. As you get into the polyatomic ions, you'll notice that often the ATE ending has some number of O's, like sulfate's SO4. Sulfite is SO3. Nitrate is NO3. Nitrite is NO2. And they always have the same overall charge. So phosphite is PO3 with a -3, and it shows up sometimes. So what I want you to do is submit screenshots of 15 correct answers. Note that names and masses are ½ a point each. I suggest sets of 5. Don't Google. I will recognize some answers as Googled. I won't recognize them all, but I'll know that if some of your answers look like they came from the internet, I'll know that, and that'll result in a score penalty. Then you're going to round your masses to the nearest whole number. If you miss one, it'll give you the answers to the nearest hundredth, but if you had it right to the nearest whole number, it will count it correct. All right, so this is, we'll go ahead and do a couple of example problems. So when you get it, you set it up like this, and this is in the screenshot. So we want to click both, names and formulas and molar mass. We're going to uncheck acids because I haven't taught you very much about acids yet. We'll click on chemical names, and then you're ready to go. It generates a quiz. It's going to give us 5 questions to do. All right, so we'll just do these as examples. Josh is going to answer your question, so when we get to the second column. All right, maybe I'll change, let me go back to my camera just a second. Let's see if I can do that. I'm going to stop the sharing just a second. If you pin the window, actually I don't think I need, I was going to write it on paper, but I don't think I need to. I can just do it on here. Okay, so copper 2 nitrate would be Cu, or it says nitrite. Now copper has a +2 charge. So if it has a +2 charge, and nitrite is a -1 charge, would it make sense to say we're going to have 2 of the nitrites? And so if we have 2 of the nitrites, get in the chat where I can see it. All right. If it says we have 2 of the nitrites, then we know that we have to have a parentheses around it because it is a polyatomic ion, and we'll have to have 2 outside the parentheses because this part right here, that's a -1 charge, and this is a +2 charge. And we know it's 2 because it says 2 right here. All right, now the molar mass. If you look on a periodic table, it'll tell you that copper is 64. It actually says 63.5, but you can round to 64. Then we have to add what's in the parentheses. So the nitrogen, if you look on the periodic table, it will tell you it's 14. And we have to add the 2 oxygens that are inside the parentheses. Now again, I'm considering at this point this 2 right here. So 2 oxygens will be 16 times 2. The oxygen on a periodic table will be 16. And now I've covered everything that's in the parentheses. But I still have to multiply the stuff that's in the parentheses by 2 because there's a 2 outside the parentheses. All right, so now I've got 14 plus 16 times 2. So 16 times 2 is 32, plus 14 is 46. 46 times 2 is 92, right? 46 times 2, 92. Then I'd have 92 plus 64, and 92 plus 64 is 156. So that would be our molar mass. All right, so this is, now we run into the next one, boron trichloride. So the symbol for boron is B. Are we going to need to look up charges for this, or can we just use what I taught you a minute ago? Just use our skills, can't you? So what's tri mean? 3. So we just say BCl3. All right, then you go look on a periodic table. Maybe I'll show you, if I can figure out how to get there real quick, where the periodic table is. Here we go. If you go to the periodic table, you can see that boron is 10.81. Be sure you round those off to the nearest whole number. So that's 10.81. And if we go to chlorine, it's 35.45, so you just call it 35. Oh, shoot. I just hit the wrong button and lost my thing. Shoot. Oh, well. So we'll try it one more time. Do another one. So I set it up. We want both of those. We uncheck that. We do chemical names. And start. All right, here's another quiz. All right, so let's do number 3. So tetra arsenic hex oxide. So arsenic is AS. Tetra would mean 4 of them. And then hex oxide would mean oxygen. And hex meant 6, so it'll be O6. So then you have the weight of arsenic times 4 plus the weight of oxygen times 6 when you do the mass over here. All right, are there questions about this right now? Do we understand that you first write the formula and be sure you get it correct, and then your molar mass will fall in line? Remember that when you have a compound like this, magnesium chlorite, magnesium's plus 2, chlorite's minus 1. So you have to have 2 to the minus 1. So when you have something like that, you add up what's in the parentheses and multiply it by 2, then add the mass of the metal. All right, so I'll grade those two. It'll give me a score on those two. So when you're finished, you'll submit this page, and you get a half a point for every correct over here. Like this would be worth 1 out of 5. All right, make sense? All right, so what we're going to do then, I'm going to open up breakout rooms, and I'm going to open them, and you can join them and move around. Oh, wait a minute. Hang on just a minute.
Do we gotta be in the breakout rooms?
Yeah, you can be with somebody if you want to, but I was hoping to get people working together, and I was going to try and come around. Actually, I don't. If you want to go, if you want to move, if you want to stay here, I guess you can. But if you would like to have a little privately or just work with 1 or 2 people, you can do. All right, I'm looking at my settings here, and I think I've set it now so that you can pick your own rooms. So I'm going to open them, and you should be able to move into the breakout rooms. All right, got it?
Mm-hmm.
Okay. And if you want to go join a different room, you can. I mean, you can move. Can you see all the rooms, and you see who's in the rooms? You can move around with each other. Okay, if you're still here, go ahead and join a breakout room.